Let's think a little bit more about the impedances and the coupling on these AC coupled linear single transistor amplifiers. So here's our model. It was similar to a inverting op-amp amplifier, and our gain here was negative, and it was minus R1 over R2, and the output impedance was that value, R1. In this case, in the example we're going to be using here, this is 1,000 ohms and this is 100 ohms. So our gain here is negative 10 and our output impedance is 1,000 ohms. And we've biased this by creating this voltage divider here to bring the base to just such a voltage that the output voltage is 2.5, and that gives it plenty of room to roam to lower voltages and to higher voltages as this behaves as an amplifier. So the output impedance is 1,000 ohms, and this DC blocking capacitor here forms an RC filter. It forms an RC filter where the time constant is like 1,000 ohms times that value of capacitance C0. So if we want this to be a good amplifier even at low frequencies, we are going to have to choose a large value of C0. It can even turn out to be inconveniently large if you want to get down to low audio frequencies of like 20 hertz, for instance. Likewise, the input is also AC coupled. Here, the input impedance is the lower of these two, and a good pair here that gave us the desired 0.85 volts that we wanted. A good pair here was 47K and 10K. That gave us about the right voltage here. The input impedance is now like 10K. So again, we've got a time constant to be concerned about, which is the product of C1 and that 10K. And so we better make sure that in our attempt to couple an AC signal into a biased voltage here, near 0.85 volts, we better be careful that our time constant is sufficiently long.